So we've now defined a normal distribution, and we've talked about how to find z-values for a distribution, but now we're going to move to the standard normal distribution. And standard normal distribution just has two main properties. Our mean is 0, and our standard deviation is 1. So the real reason we like the standard normal distribution is because we can understand that area under the curve, under our normal curve, is going to be equal to probability. And while this is not something you may want to necessarily find the area under, we do have tables that give us the area to make this a lot easier. So first we'll discuss how to exactly find the area given a particular z-value. The first case we'll look at is area to the left of a particular z-value. So our graph looks like this. We have a normal distribution, we have a z-value, and we want to know the probability that you are smaller than that z-value. Well, we're just going to look it up. And like I said, there are tables to do this, and in a second, whenever we do examples, we'll actually show you how to use the tables. Next, we'll look at how to find the area to the right of a z-value if we want to know what's the probability that you're bigger than a given z-value. Well, our tables always give us the left-hand area, so we can no longer just look up the z-value. However, that is still the first step. But there is an added step in here. So the table always gives us the area to the left, and we know that the total area is 1. So when we look up the z-value, it gives us this area to the left. And so all we need to do is then subtract that value from 1. So we'll do 1 minus the number we find in the table, and then we have the area to the right. The final case is looking between two values. We want to know the area between two given z-values. Well, once again, the first step is going to be to look up the z-values, in this case, both of them. When we look up the one to the right, it's going to give us all of this area to the left. However, you'll notice that all of this part is extra area that we don't want. However, if we look up the number z1, it's going to give us all of this extra area that we don't want. So once we have these two values and we look them up in the table, we just need to subtract. And we should always deal with positive numbers, so make sure you subtract the biggest minus the smallest. Now let's do a few examples. The first one we're going to do is find the area to the left of the z-value 1.65. Usually the easiest thing to do is to start with a normal distribution. We know that 0 is at the center, so 1.65 has to be somewhere over here to the right. And we want all of this area to the left. So in order to find area to the left, we just have to look it up in our table. So let's move over to our table and learn how to read it. This is our normal table, our standard normal z table. And the way we're going to read this is to start by looking for the number in the first column. So we have 1.65. The first page is usually all the negative numbers, and then if we move to the second page, we have the positive numbers. So you look up, in our case, we're looking up 1.65. So we start with 1.6, and then we find the 5 along the top, and then we just see where they meet. And these numbers meet at 0.9505. So that tells us the area to the left of 1.65 is 0.9505. Next, we're going to find the area to the right of negative 0.21. So negative 0.21 is somewhere here, and we're looking at area to the right. The first step is still going to be to go to our table. So here's our table. We're looking for negative 0.21. So in our first column, we're going to find negative 0.2. And then along the top row, we're going to look for 0.1. And so we see that we have this value, 0.4168. Moving back, we found 0.4168 in our table, And since we're looking for area to the right, we need to do 1 minus this value. And that's going to give us 0.5832, which is the area to the right of negative 0.21. This time I want to find area between negative 2.03 and 1.07. So we have negative 2.03 somewhere to the left and 1.07 somewhere to the right. And in order to find this, we need to go back to our table and look up both of these values. Our first value was negative 2.03, so on the left we'll go down to negative 2.0, and on the top to 0.03. And we see that they meet at this value, 0.0212. We also need to look up our other value, which was 1.07. So we'll move to the positive side. The first column, we're looking for 1.0. And then we want to see where that meets at the 7 along the top. And we can see that we have 0.8577. Moving back to our example, we had this one corresponding to 0.8577 and this one corresponding to 0.0212. And now we just need to subtract these values. And when we do, we get 0.8365.